Welcome to the Planet of Maths channel. In today's episode, we will talk about rational exponents, that is, fractional. Here we have a formula, and this formula tells us that if we have a number to be raised to a fractional power, then our number goes under the root. The denominator of a fraction is otherwise known as the root's degree. The numerator of this fraction is the exponent. Here we will raise it to the power corresponding to the numerator. That's what the formula says, but how it works in practice. 9 to the power of 1/2. If there's a fraction in the exponent, then a root must appear here. Under this root will be the number 9. It jumps here under the root. The number of the denominator, which is the number 2, represents the degree of the root, so this 2 goes here. We take 1 from the numerator and put it to the exponent. It will be 9 to the first power. So we operate according to our pattern. Now we write this a bit differently, because if we have a square root, then we don't write this 2. If we have 9 to the power of 1, it's the same as 9. So we have the square root of 9, and the square root of 9 equals 3. 16 to the power of 1/2. Since there's a fraction, it must be a root. The number under the root is this one. 16 pops up here. The denominator of the fraction, it's the degree of the root, so it's 2 here, and we don't write this 2 anymore. And the numerator, this one goes to the power. Here's 16 to the power of 1, but we also don't write the 1. So we have the square root of 16, which is 4. 64 this time to the power of 1/3, so we have a root again. The number 64 goes under the root. 3 represents the degree of the root, so we have a cube root. And 1 goes here as 64 to the first power, and we don't need to write this one. And the cube root of 64 is 4. The next example is 6 to the power of 2/3, and according to our formula, right after the equal sign, we definitely have a root. This number 6 jumps under the root. The 3 from the denominator goes as the root degree, and the 2 from here is raised to the power here. It will be 6 to the second power. And now we can also exponentiate this 6 squared, so finally we get the cube root of 36. And such a root can't be calculated anymore. We leave the result as it is. 8 to the power of 2/3. Following what we've done so far, we can do it this way. With a fraction, a root appears for us. Under the root, there will definitely be an 8. The 3 from here goes to the root degree, meaning the cubic root, and the 2 from here goes to the exponent, that we will have 8 to the second power. As in the previous example, we can take this 8 to the second power. We end up with the cube root of 64 because 8 times 8 is 64. And the cube root of 64 is simply 4. This example can also be done in a slightly different way. That's why there are these two formulas here. So far, we have been calculating according to this formula. This exponent always appears here under the roots. Well, it might be a bit different. 8 to the power of 2/3. We start the same, which means there's an 8 under the root. The degree of the root, which is this 3 here, goes here. This 2 is coming here. Now you can also do something like this, where the power from here, it can jump out of the parenthesis. We can use parentheses. In these parentheses will be the cube root of 8, and this 2 will migrate out of the parentheses. Now it turns out that the cube root of 8 is something we can calculate. The cube root of 8 is 2, so we're going to have here 2 squared, which is 4. 81 to the power of 3/4. First, the root. Under the root is 81. The 4 from the bottom is the degree of the root, so it's a 4th degree root. The 3 from the top goes as a power of the number 81, 81 to the third power. And here again, we'll take this power out of the bracket. So we have that root that was here, but without the 3. Means the 4th root of 81. And this 3 comes out of the bracket. So now we can calculate what's inside the parenthesis, which we have here. It's the 4th root of 81. That's exactly 3, because 3 raised to the 4th power, which is 3 times 3 times 3 times 3, gives a result of 81. What comes out of the parentheses gives us the number 3. It was also raised to the 3rd power, so it is 3 to the 3rd power, which is 27. In the next example, we have 4 to the power of 0.4, which gives us a decimal fraction, but it is still a fraction. And such a decimal fraction we always have to convert to a common fraction. That is 4 to the power of 4/10. We notice that 4/10 can be reduced, so it will be 4 to the power of 2/5. And now we proceed in a familiar way. A square root appears. Underneath the square root will be 4. The degree of the root will be 5, as it comes from the denominator, and 2 is the power of 4. 4 squared means to the numerator's power. And here the only thing you can do is calculate what 4 squared is. 4 squared equals 16. The fifth root of 16 comes out in this example. The next example is 81 to the power of negative 1/2. The minus sign complicates things a bit. We need to start with this minus sign. The minus says that we need to draw a fraction line here. Put a 1 in the numerator, and in the denominator, it's what is here, but without the minus. So it's going to be 81 to the power of 1/2. Nothing changes in the numerator here, it remains a 1, while in the denominator, 81 to the 1/2 power is going to be the square root, because the exponent is a fraction. The 2 is the degree of the root, so here we could write a 2, but since it's a square root, we don't write it. Under the square root will be the number 81 raised to the power from the numerator. If there's a 1 here, you'd have to raise 81 to the first power. But we don't have to write this one. We rewrite one, and in the denominator, the square root of 81 is simply 9. So it turned out to be 1/9. Another example, we have 625 to the power of minus 1/4. Since there's a minus in the exponent, we need to put a 1 on the top. And at the bottom, we put everything that is here, but without the minus. That means 625 to the power of 1/4. The 1 on top doesn't change, but there will be a root at the bottom. This root will be of the degree that is the denominator, that is of the 4th degree, and under the root will be the number 625. To the power of the 1 in the numerator, that is, to the first power, here is 1, but we don't have to write it. And now the final result is the same as the 4th root of 625, which is exactly 5. Next example, 4 to the power of negative 3/2. Since it's negative, we make a fractional line. At the top, we put 1, and at the bottom we put everything that is here, but without the minus, which is 4 to the power of 3/2. Minus has already worked. Now this fraction must work. Since the fraction is in the exponent, meaning we have a root, the root is of the degree as the denominator, so it is a square root, but we do not have to write the 2. Under the root will be 4 to the power as in the numerator, that is to the 3rd power. So now what can we do here? We can raise 4 to the 3rd power. 4 times 4 is 16, and again times 4 is 64. We get the square root of 64, which is simply 8. So it turns out to be 1/8. Now we have a task to express the given numbers as a power of 2, and we have the cube root of the number 2. As a result, we will have 2, and to a fractional power it will definitely be, so here's the fractional line. The degree of the root is 3, and we add that to the denominator. In the numerator, we add what the power is here next to the number 2. Until now, there was an invisible 1. Once we write it down, we clearly see that it is 2 to the power of 1/3. Next example. We no longer have the number 2, we have 16, but we'll figure it out. First, however, a root, so it will be like this, 16 to the power of a fraction. The degree of the root goes to the denominator, so here it is 3, and at the top, in the numerator, will be what is here in the power. 16 is to the power of 1. So here we have 1 in the numerator. Just that right now, we don't have a power of 2 here. But in this table, where we have powers of 2, we notice that 2 to the power of 4 is exactly 16. Using this, we can handle the number 16, convert to 2 to the 4th power. Here in the parenthesis, instead of 16, we have 2 to the 4th, and then to the power of 1/3. So we've got that 2 we wanted. Now it's just enough to exponentiate the exponent. And it works like this. Multiply 4 by 1/3. This comes out to 4/3. The 4th root of 64 is going to be 64 to a fractional power. 4 is the denominator. The degree of the root always goes to the denominator, and in the numerator it's going to be this so far invisible one. Just like in the previous example, we'll use our table and find out what equals 64. 64 is otherwise known as 2 to the power of 6. So in this bracket, we can put 2 to the 6th power. And outside the bracket, we still have a fraction of 1/4. And that it's going to be 2 to the power and then 6 times a quarter, which gives us 6 quarters. Because 6 wholes is 6 ones, so 6 times 1 is 6, and 1 times 4 is 4. And that would be the result, just need to simplify it, and it will be perfect. Simplify by 2, and we get 3/2. Another example is a fraction. Here we have a cube root of 0.25. First, we handle the cube root. So we will have 0.25 raised to a fractional power. In a fraction, the root degree goes to the denominator. In the numerator, there will be the exponent, so here again, an invisible one, it goes up. Cube root is done, now we need to deal with the fraction. 0.25 is obviously 1/4, so we can write that as 1/4. Instead of decimal fraction, we put in common fraction, and it is to the power of 1/3. 1/4 is otherwise 4 to the power of -1. That's how negative powers work. And then it's going to be to the power of 1/3. Here we can multiply these exponents. -1 times 1/3, that is -1/3. And it would be nice if we could bring it down to the 4th power, but we need to get to 2. Using our table, we know that 4 is 2 to the 2nd power. 2 to the 2nd power, instead of 4 here, we have to the power of -1/3. And now we can write the final result. It is 2 raised to the power. And we multiply 2 by -1/3, which gives us -2/3. And now the last two examples. We keep converting all this to the power of 2. Let's go step by step. 8 can be converted to 2 to the power of 3. Here we have an implied multiplication, so we multiply. And here we deal with the root, so we will have 4 raised to a fractional power. In the numerator is 1, because it is 1 from here, and in the denominator we put the degree of the root, which is 3. 4 raised to the power of 1/3. 2 to the power of 3 I leave as is, because it suits me. And here I still need to deal with this 4. This 4 is otherwise 2 to the power of 2. In the bracket I have 2 squared, and outside the bracket I have another 1/3. 2 to the power of 3 unchanged. Here I can multiply 2 times 1/3. 2 times 1/3 equals 2/3. And I have 2 to the power of 2/3. We have the same bases, then this base remains here. And I need to add the exponents together, so it is 3 wholes and 2/3. That's the result of this example. Here you can also write it as an improper fraction. It will be 2 raised to the power of 11/6, if anyone wants it in an improper fraction. And for the last example, 16, we know what to do with it. We change 16 to 2 to the 4th power. I'll leave the square root for now, but this time we can also convert this 8 into 2 to the 3rd power. 2 to the 3rd power is the same as 8. It equals 2 to the 4th power times this whole root, it's of the 2nd degree. So such a root can be converted into 2 to the power of a fraction. The degree of the root goes to the denominator. In the numerator, there's this power, which is 3. Here are these two numbers again. We have to add them together, this 4 and 2/3, but first, I will separate out the wholes. That is 1 whole and 1/2. Now I add these exponents together, it gives me 2 to the 5½ power. And if someone wanted it as an improper fraction, that would be 11/2. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Mass channel.